Let's practice simplifying complex, aka imaginary, expressions together. For number 1, we have the square root of negative 18. Now, if you ever have a negative value inside the radical, I recommend just separating this into the square root of negative 1 times the square root of a regular 18 or a positive 18. Now the square root of negative 1 is equal to I, so that's what we're going to write over here. And then the square root of 18, think of two factors where one is possibly a perfect square. In this case, I'm thinking 18 can break into the square root of 9 times the square root of 2. Okay, since 9 is a perfect square. So let's again keep this I in front here. And then the square root of 9 that we have here, that's equal to 3. So we'll go ahead and write times 3. And then the square root of 2 is irrational, so we're just going to leave it alone. So our final answer here is going to be 3i times the square root of 2, or 3i root 2. For number 2, we have a negative square root of negative 75. So a negative in front, keep in mind that there is an invisible negative 1 out here. So I'm just going to go ahead and write it so it's super clear. So we have negative 1 multiplied by the square root of negative 75. Now for the square root of negative 75, what I'm going to do is just like in the last problem, I'm going to make that square root of negative 1 multiplied by the square root of a positive 75, okay? So we separated into a few different pieces here. That negative 1 in front, just writing it to be super clear. And then that square root of negative 1 is equal to I. Now for the square root of 75, what I'm thinking of breaking this into is a square root of 25 times the square root of 3, since 25 is a perfect square. If we multiply this negative 1 times I, that's really just going to be a negative I, okay? And then the square root of 25 is equal to 5, so we'll multiply that by 5. And then root 3 is really just an irrational value, so we'll keep that the same. So at the very end here, if we write our answer, let's just rearrange and say this is going to be negative 5i times the square root of 3, or negative 5i root 3. This would be our simplified expression. For number 3, we have I times the square root of negative 48. So right from the beginning here, let's just go ahead and leave this I alone in front. And then let's separate the square root of negative 48 into, let's see, we'll do the square root of negative 1. And then we'll multiply that by the square root of 48. Okay, now let's go ahead and go one step further here. Now I in front is going to stay here, and then the square root of this negative 1 is also equal to I, so we really have I times I outside of the radical. And then for the square root of 48, I'm going to break that into the square root of 16 times the square root of 3, because 16 is the biggest perfect square factor for 48. Okay, now if you multiply this I times I together, that is going to get us I squared in front. The square root of 16 is equal to 4, so we'll have this multiplied by 4, and then we have the square root of 3 that's irrational. Okay, now we can go ahead and take this I squared. Remember, I squared is equal to negative 1, so I have negative 1 times 4 times the square root of 3, and then negative 1 times 4 is equal to negative 4, so this simplifies down to negative 4 root 3. This would be our most simplified expression. All right, so for number 4, this one looks a little bit different because we have a fraction, but try to treat it the same. There's just some other rules we have to keep in mind. So what I'm gonna do first is, instead of having a negative 3/4, I'm going to take a negative 1 and separate that out. And then so we're just gonna have the square root of a positive fraction instead. So it's gonna be 3/4. Okay, now if we go ahead and do that, then the square root of negative 1, we've done a few times now, that's just going to be I. Okay, and now when we're dealing with a fraction underneath a radical, then one of our properties with fraction and radicals is that we can separate this into two different radicals, one in the numerator and one in the denominator. So keep in mind that goes both ways. Okay, and so we have this I in front, which is easy enough to deal with. It's going to tack that onto our answer, but then the root 3 on top is irrational, so that's going to stay the same. But then the square root of the 4 on bottom is just equal to 2. Okay, so this is as far as we can go, and we have a rational denominator as well, so that 2 is good on bottom. And so if we want to rewrite this into standard form like all our other ones, or other solutions or most simplified versions, we'll write the square root of 3 over 2i. All right, this would be our most simplified expression. Here's number 5. For number 5, this one's pretty similar. Let's start off by just separating this into a negative radical, like the square root of negative 1. and then we'll multiply this by a positive radical, we just have this 2/5 inside of this one, okay? Now the square root of this -1 is equal to I, so let's go ahead and just write that. And then for the square root of 2/5, remember we can split this into two different radicals. So we have the numerator, the square root of 2, and the denominator, which is a square root of 5. Now at this point, you want to remember that we actually want to rationalize the denominator, so this square root of 5 on the bottom is something we want to try to get rid of. Now what we can do is multiply this by the square root of 5 over the square root of 5, which is really just 1, right? Because the root 5 over root 5 is just 1. But what we're going to notice here is that the root 5 and root 5 on the denominator will just become a rational value, or just the number 5, right? Now multiplying this root 2 times root 5 on top, just like we've been separating, we can put those back together. And so 2 times 5 is 10, so that will be the square root of 10. And on the bottom here, the square root of 5 times square root of 5 is just going to equal 5. And so we can go ahead and write that in the denominator. So at this point, we have a rational denominator, which is good. So we can write this as root 10 over 5 I. This would be the most simplified expression for this complex number. For number 6, we have another fraction here. This time looks like they're already separated though. What I'm going to do for my first step here is I'm going to take this square root of -6 and split it. So in the numerator, I'm going to split this into the square root of -1, and I'm going to multiply that by the square root of a positive 6. And in the denominator, I'm just going to keep this square root of positive 2 for now. Now, the square root of that -1 is going to be I, so I'm just going to write I times the square root of 6 over the square root of 2. Okay, so we're in the right direction here, but we have to make sure that the denominator is rational. So to get rid of this irrational value on the bottom, we can multiply by the square root of 2 over the square root of 2. Now, what happens in the numerator here is the square root of 6 multiplied by the square root of 2. That's going to be the square root of 12. So we can write this as I times the square root of 12. That's going to be in the numerator. And in the bottom, or in the denominator, root 2 times root 2 is just going to equal 2. Okay, so we got this so far. Now it looks like we're almost done, but this square root of 12, I think we can simplify it more, right? So we can actually break that 12 into, I think, 4 and 3. So we have I times, and then the square root of 12 can break into the square root of 4 times the square root of 3. This is all over 2. And the square root of 4 is going to be 2, so we're really going to have I multiplied by 2 times root 3 all over 2. At this point, notice that we have a 2 as a common factor, or the GCF of the top and bottom, so we can divide both top and bottom by that. And so our final simplified expression is going to be I root 3. This would be our final expression. And this is just a little bit of a bonus shortcut, but if you go back to this step over here, you might have noticed that if you know your rules pretty well with radicals, that you could actually just divide 6 by 2 to get 3, and that would be the same thing as this root 3 as well. I just wanted to be super detailed, but that's also something that you can do. Here's number 7. Now for problems like these, there are some different strategies that you can try, but I'm going to try to be as consistent as possible with what I've been doing in this video. Let's take this square root of -2 and break that into the square root of -1 multiplied by the square root of a positive 2. And for the square root of -32, let's do the same thing. So let's multiply that by the square root of -1 and then multiply that by the square root of this positive 32. Okay, so if we go ahead and do that, then we're going to have the square root of -1, which is I, and we're going to have another I. That's going to come from the square roots of each of these -1s. And then we're going to have the square root of 2 here. Okay, that's going to stay the same, this root 2 and root 2. We didn't do anything with those yet. And then for the square root of 32, let's go ahead and break that into some perfect squares. So 16 times 2 is 32. So I think that would kind of be our best bet here. Okay, now in front here, I times I, that's going to get us I squared. Okay, and then we can go ahead and say, okay, let's take the square root of 16, and that's going to equal 4. Go ahead and write that. And then this is irrational and this is irrational, but the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 just equals 2, right? So if you multiply this root 2 and root 2 together, you actually just get 2. And then we can also see here that this I times I got us the I squared, and then this square root of 16 equaled this 4. So that's where everything came from. Okay, now this I squared is equal to -1, so we can go ahead and write this is going to be -1 multiplied by 4 multiplied by 2. And so negative 1 times 4 times 2 is just equal to negative 8. So that would be the most simplified version of this expression. Here's number 8. For number 8, what I'm going to do here first with this square root of 35, it's already positive, but what I'm going to do is actually I'm going to separate this into the square root of 5 times the square root of 7, because I really want it to kind of match with the root 7 we're going to get in a little bit. For the square root of negative 7, let's go ahead and get that negative 1 out. So that's the square root of negative 1. Let's multiply that by the square root of a positive 7. So you can see that I was pretty strategic here in trying to get these two root 7s in this problem because they're going to cancel out nicely to make a rational number. Now, the square root of negative 1 is equal to I. Let's go ahead and write that. And then the square root of 7 times the square root of 7 is just equal to 7. All right, so we can just write times 7. And then we have this root 5 that we can't really do anything with because that one is just irrational, right? So remember, square root of 7 times the square root of 7 is the square root of 49, and the square root of 49 is equal to 7. Okay, so one final step, just rearrange a little bit. This is going to be 7i root 5. This would be our final expression. Here's number 9. All right, for number 9, what I'm going to do here is take the square root of negative 3, and I'm going to separate that into the square root of negative 1, then multiply that by the square root of 3. Then for this square root of negative 12, let's break that into the square root of another negative 1, but then we'll multiply that by the square root of 12. And then for the square root of negative 4 here, let's go ahead and break that into the square root of negative 1, and let's multiply that by the square root of positive 4. Alrighty, so if we take a look here, we have the square root of negative 1 3 times. So that's going to turn into I times I times I. All right, and then we have the square root of 3. We can't really do anything with that. Let's just leave it alone for now. Now for the square root of 12, I'm going to strategically break that into the square root of 4 times the square root of 3. That works nicely for two reasons. One, because we have two of these root 3s, which is nice. And then you're going to notice that we're going to have two of these root 4s. We have one more of these root 4s at the end here, okay? Now if we multiply I times I times I, that's gonna get us I to the third power, or I cubed. And then if we go ahead and multiply this square root of 3 times the square root of 3, remember that's square root of 9, aka just 3. And then the square root of 4 times the square root of 4 is the square root of 16, which is really just 4. Now it's really helpful to know your first few powers of I, but I to the third power is equal to negative I. So let's go ahead and write that as negative I multiplied by whatever 3 times 4 is, and that's going to be 12, right? So rearranging this bit, we will have negative 12i as our final expression. Here's number 10. For number 10, let's go ahead and break this up, this square root of negative 4. We can go and write the square root of negative 1 multiplied by the square root of a positive 4. We'll keep this root 2 alone and leave it alone for now. The square root of negative 8, let's go ahead and break that into the square root of negative 1. Let's multiply that by the square root of this positive 8. And then for the square root of 4, let's leave that one alone right now. It's a perfect square and it has a positive value. Next, we're going to take these square roots of negative 1s. Each of them are going to become I, so we can write I times I in the beginning here. And then we can go ahead and take this square root of 4 and square root of 4. That's going to multiply together to make square root of 16, but the square root of 16 is equal to 4. So those radicals just cancel each other out. Then we have this root 2, which is irrational. So let's go ahead and keep that the same for now. And then for this root 8, I think we have a perfect square hidden inside, like 4. So we can break this into the square root of 4 times the square root of 2. Okay. Now, next we have I times I. That's equal to I squared. Go ahead and write that. And then we have this 4 here. I'm just going to leave that alone for now. I'll just write times 4. And then we have the square root of 2 times the square root of 2. That's just equal to 2. So I'll go ahead and write times 2. And then the square root of 4 here is equal to 2. So we can also write times 2 at the end here. All right. Now, I squared, this value here, is equal to negative 1. So we'll change that to a negative 1. And then 4 times 2 times 2 is equal to 16. So multiply this by 16. And then negative 1 times 16 is equal to negative 16. Here's number 11. So for number 11, what I would do first here is just go ahead and rewrite these fractions and write these radicals so we have positive values inside of them. So square root of 3 is positive, we'll leave that alone. For the square root of -6, let's go ahead and break that into the square root of -1 and multiply that by the square root of a +6, right? And then for this square root of -2 on top, let's go ahead and break that into the square root of -1 and then multiply that by the square root of a +2. Now, in the bottom of this fraction, we have the square root of 9, and that's a perfect square, so while we're at it, let's just go ahead and turn that into a 3. All right, so moving on, we are multiplying fractions, so we can just write one fraction bar. The square root of 3, let's just leave that alone for now. Let's write root 3, and then let's go ahead and take the square root of -1 and just say we're multiplying that by I. And then we have this root 2 as well, so let's just go ahead and write times the square root of 2, okay? The square root of -1 on the bottom, that's going to be I. And then the square root of 6, we can actually break that into the square root of 3 times the square root of 2, even though neither of those are perfect squares. I just want to make them cancel out with the ones on top. And this 3 here is what we're going to have in the bottom. At this point, we just have one fraction where everything's being multiplied together. So this I over I can cancel out. This root 3 and root 3 will cancel out. And this root 2 over root 2 will also cancel out. So this whole expression really boils down to just being 1/3. Here's one final example. For starters, let's go ahead and break apart the square root of -5. So I'm going to go ahead and write that's going to be the square root of -1 multiplied by the square root of a +5. That's going to be on top. And then for the square root of -24, let's go ahead and break that into the square root of -1 multiplied by the square root of a +24. Okay, so that's how I'm rewriting that first fraction. And then dealing with this radical over here, what I'd like to do is break it into the square root of -1 and then multiply that by the square root of that fraction, which is really just this 10 over 3, but at least it's now a positive fraction. Okay, so let's go ahead and break this down a little bit more. So the square root of -1 and square root of -1, that's going to be I times root 5 on top here. And on the bottom, we're also going to have another I. We'll cancel those out in just a moment. If you want to do those now, feel free to do so, okay? And then we're going to multiply this by the square root of -1, which is really just I. And then for this fraction here of root 10 over root 3, I'm going to go ahead and separate that into a numerator of the square root of 10 and a denominator of the square root of 3. All right, so now in this next step, I'm going to cancel out these I, since I over I, or anything over itself, is equal to 1. And let's try to just write one fraction bar now, since again, we are multiplying. So the square root of 5, I'm just going to keep that over here as the square root of 5. This I, really, if it has to go anywhere, has to go on top, right? So I'm going to write times I here. And then for this root 10, even though it can't be simplified in terms of having a perfect square, I'm going to break it up into root 5 times root 2, since that is the same thing as the square root of 10, and you'll see why in just a moment. For the square root of 24, let's go ahead and break that down into some smaller pieces. So I think there's a 4 hidden inside of there. That would be 4 times 6. But 6, let's break into 3 and 2, right? So I actually broke this root 24 into 3 pieces just because that's going to help us a little bit with dealing with the root 3 at the end. So we have one more root 3. Let's go ahead and write that underneath here as well. Okay, so again, this root 5 turned into this root 5, didn't do anything with it. This I that's in the middle, when you write it as a fraction, always goes in the numerator by default. The square root of 10 can't be simplified, but I chose to break it down into these 2 factors anyway. The square root of 24 actually broke it down into 3 factors, just because we're going to see something nice that will happen here. And the square root of 3 is the same thing as square root of 3. Okay, so let's clean this up a little bit. So let's go ahead and take this I and just write it in front, since that can't be broken down right now. And then if we go ahead and multiply the square root of 5 times the square root of 5, remember that's just equal to a regular 5. We can go ahead and cancel out this root 2 over root 2, which is kind of nice for us, okay? And then let's go ahead and see now what's going to be in the denominator, right? So in the denominator, we have the square root of 4, which is just equal to 2, right? And then we have the square root of 3 times the square root of 3, which is equal to 3. All right, so after all that, a lot of these radicals go away, and we actually have just no radicals, which is kind of nice. So on the top, we have 5 multiplied by I, and then in the bottom, 2 times 3 is going to be 6. So at the very end, we can go ahead and write our simplified expression as 5, 6 as a coefficient for I. This would be our most simplified expression. All right, so there you have 12 different practice problems with simplifying these expressions with imaginary complex numbers. If you found the video helpful, please consider giving this video a thumbs up. And as always, keep up the great work. I'll see you in the next one.